we're going to look at the divergence of a vector field in Matlab. So I've created an M file which is available to you, and it will be in the resource section of this video, called divergence.m. So in that I've generated a couple of examples. So we'll go to the second example and we'll have a quick chat through it. So we have a vector function here, and its I component is here and the j component is here, and we've plotted out that vector function, and you can see that in the yellow area the arrows are heading outwards, so that is going to be a source. So if you like, in terms of divergence, it's going to be an area of expansion, and in the blue area all the arrows are heading in towards the centre. So if you like, that's going to be an area of compression, or it's going to be a sink. So we've said that a source is going to give a positive value for the divergence, and the sink will give you a negative value for the divergence. And you can see that here because the yellow region here has got a positive value here for the divergence, and the blue region has got a negative value there for the divergence. So you see the divergence is just going to be a scalar function of the position. So let's go ahead and we'll have a wee look at it in Matlab. Okay, so this is the function in Matlab called divergence.m. Now we'll just run through this example, and then afterwards we'll have a quick look at the program. So when you run it up, it's going to ask you for the I component of the field. So in this instance here, we can just call that minus sine x times sine y, and then ask you for the j component, which is going to be cos x times or cos y. So that's generated two figures. So the first one, figure 1, is just the vector field, and the second one is the divergence. So I'll get it so it's sitting in the right angle. Okay, so that's I along there and y along that axis, and again we're going to have our x along that axis and y along that axis. So that's the same as we've seen just in the previous example. Okay, so that's the vector field and that's the divergence. The only difference is there's no contour map on this one. Okay, so we can see then, as we've seen in the previous example, we've got the area here which is going to be our source, and this area here is going to be our sink. The source are going to give us a positive value for the divergence, and the sink we're going to give us a negative value for the divergence. So let's have a quick look at the code. So it requests the I component and the j component. It places the function in a variable called x in, and a function for the j in a variable called y in. It then takes that function, which is a symbolic function, and generates the actual values on a grid, and produces a quiver plot, okay, which is really just us producing the vector function, and all the rest of it's just to format the output so as it looks neat and tidy. We then calculate the divergence, so there's only three simple lines there in order to generate the divergence, and then we plot the divergence of the function, and again this is just done with this function here, the surf f, the divergence, and it just puts in the limits, and the rest it's just for formatting the actual graph, the actual figure. So that's all there is to this part. Now you can go ahead and use that and have a little try with it, put in a few examples, and it's a good way of kind of understanding the divergence. Now you'll actually get better understanding the divergence whenever we go in and we have a look at the gradient and also the Laplacian, but we haven't introduced those as yet, so I didn't want to introduce those or talk about them at the moment, but it'll all come clear as well why we're doing this whenever you see the gradient and also the Laplacian. One other thing, if you wanted to actually calculate the divergence of a function, you could just use these simple lines here. Okay, so you can put in your field, which is really just the function in terms of the I coordinate, the j coordinate, and also a z coordinate, and then you can just use this simple section here, divergence of the field in the variable x, y, z. And note here, we've only generated the divergence in terms of a two-dimensional vector field. It just makes it simpler for us to see what's going on. Okay, so thank you for listening, and I'll get you on the next video. Okay, bye bye.